Hello students, let's continue with the chapter from geography, the dynamic earth. In the last session we have studied about the theory of continental drift, the tectonic plates, the movements. Okay, out of that some movements that today we are going to continue. So endogenic movements that we are studying and today we are going to study in detail about the sudden forces. These forces, it means these sudden forces, these forces are responsible for massive events such as volcanic eruption, earthquakes, etc. Okay, so the forces or the activities that are generally performed inside the earth, what creates the movements of the tectonic plates, as well as it creates the energy. So these forces, out of these forces, sudden forces, these sudden forces, they can cause the volcanic eruption, earthquakes. It means from the inside of the earth these forces are made, and it is because of that the earthquake happens or the volcanic eruption happens. So the first we are going to study in detail about, that is the volcanoes. A volcano is an opening in the earth's crust through which lava, volcanic ash and gases escape. See, when the eruption of volcano is done, what happens that time? The volcano, that is lava, that is a molten magma, we say, inside the earth. So that comes out, volcanic ash and the gases that comes out with the eruption of volcano. During the process of volcanic eruption, ash, water vapor, various types of poisonous and inflammable gases, hot molten magma, etc., are thrown out from the mantle of the earth onto the surface of the earth. Okay, it means all these things which are gathered in the mantle of the earth. What are these things? That molten magma, inflammable gases, many gases are there which just easily can get the fire. Then the poisonous gases are there. So as well as ash is there, water vapors are there. So such type of all things are erupted out of the mantle of the earth to the surface of the earth when the volcanic eruption happens. When the molten magma comes out on the surface, it is called lava. Okay, it means till then the magma, molten magma is inside the mantle, then it is the molten magma. But when it comes out of the mantle of the earth on the surface, then it is known as a lava. So according to the periodicity of the volcanic eruptions, volcanoes can be divided into the following types. It means periodicity, it means the frequency of the eruption of volcano. On that basis, volcanoes are divided into uh, three types mostly. The first one is the active volcano. If the volcanic eruption are regular even in the present times, then such volcanoes are called the active volcanoes. Okay, it means even in the present times, if the eruption of the volcano is present there, so then it is known as the active volcano. For example, we can take the Mount Fujiyama in Japan, okay, then Mount Stromboli in the Mediterranean Sea. So these are the examples of active volcano. So the second type of volcano is the dormant volcanoes. Volcanoes that have not erupted for a long time but may become active suddenly are called the dormant volcanoes. It means these volcanoes are not active all the time, okay, but that volcanoes get active suddenly. Okay, such type of suddenly activating volcanoes are known as the dormant volcano. So the examples of these volcano and the mounts made created by these volcanic eruptions are Vesuvius in Italy, then Mount Katmai in Alaska. These are the examples of the dormant volcanoes. Extinct volcanoes, that is the third and last type of the volcano. Those volcanoes that have not erupted for at least 10,000 years and are not likely to erupt in the future are called the extinct volcanoes. Is it? So it means these volcanoes are totally inactive. So the first that we have studied, that the volcanoes are active any time that they are just getting erupted. The second, that dormant volcano, that volcano it get activated for the sudden times or in between of the time period, particular time period. But extinct volcanoes, these type of volcanoes, it means from the last 10,000 years these volcanoes are not active, and it means in the future also these volcanoes are not expected to active and erupt. So such type of volcanoes are known as the extinct volcanoes. For example, example of the extinct volcanoes, we can take that Mount Kilimanjaro, that is in Tanzania. Okay, so that is the better example of the extinct volcanoes. Geysers are the fountain of hot water and steam. Okay, it means the fountain from the inside of the earth. The water is just thrown out by the surface or by the earth in the form of fountain. Okay, but that water, how that water is, that is the hot water and the steam. Generally the water we get from the tube wells, that is the cold water, but here the water is thrown out, that water is hot, and with the water the steam is also thrown out. So such type of fountain of hot water and steam are known as the geysers. When the magma heats up, what happens and why this happens? Because that when the magma heats up, the underground water beyond boiling point, it erupts. Okay, it means because of the heating of magma, the underground water that also get heated and it reaches to the boiling point, and because of that it comes out with the force uh, out of the surface and it makes the fountain. So these are known as the geysers. It erupts like a volcano through fissures on the surface of the earth. The examples of that: Old Faithful in the Yellowstone National Park, then Wyoming in USA. These are the well-known gases found on the earth. So the next thing that is created because of the tectonic movements of the plates and as well as the internal movements of the earth, that is the earthquake. An earthquake is one of the most destructive forces of nature. It can be defined as a sudden and violent movement of the earth's crust followed by the series of shocks of lesser intensity. Okay, it means inside the crust the molten magma is found there, and that magma, it is getting moved from place to place, and while it is making the movements, it makes the movements of the rocks inside the crust also. So because of that, one pressure created, and that pressure is converted into the energy, and that energy turns towards the surface of the earth, and because of that earthquakes are created. So these earthquakes are created because of the shocks of lesser intensity. Okay, when the intensity of that movement is less, that time the earthquakes are created. When it is more, than the volcanic eruptions are made. So since it is an event that occurs without warning, it has the catastrophic effect. Catastrophic effects means the terrible effect, disastrous effect, we can say. So when the earthquake happens, so it makes the disaster, make the dangerous effects on the surface of the earth, because buildings get collapsed and many things, that destruction on the surface, it happens because of the earthquake. So here we are going to study in detail the process of the earthquake, how earthquake occurs. I am going to show you with the help of the pictures in every slide. See here step by step how the earthquake occurs and how uh, it makes the impact on the surface of the earth. So the first and the beginning of the process is that the powerful forces push two huge masses of rock into each other. So inside the crust of the earth, these two the forces that push the two rocks with each other, and because of that pressure the energy is created. This pressure is converted into the energy by that rocks. That is the first beginning of the creation of earthquake. Then when immense pressure is released, one mass of rock gives way, slipping upwards. Okay, it means the pressure is created on the rocks in the crust, then that pressure is converted into the energy, and that energy is transferred towards the surface of the earth. It means upside of the earth, where we live here. Then you can see in the picture that in what way the energy is converted towards the surface of the earth. The generated energy is released in the form of waves. Okay, when the energy it is created, that energy is generated in the forms of waves. So how and in what way these waves are created? Here see, I'm showing you the picture of the waves that are created by the energy. These waves travel in all directions and cause tremors. Tremors mean the trembling. Okay, it is obvious that when the energy is passed, even the energy is converted into the waves, it makes the trembling. Okay, so the same thing happens inside the earth. This trembling is known as the earthquake. See here in this picture I'm showing you that in what way these waves are making the circles and in what way these waves are getting spread. Okay, so because of that, because of conversion of these waves into the energy, the earthquake it get happened. The focus is the point of origin of an earthquake. Okay, it means where there is the it means the point from where the energy is generated, where there is the energy is with the full intensity, that is known as the focus. Okay, from that focus the energetic waves are made and these are transferred to the other places. So this focus is the main point from where the earthquake occurs. The point on the earth surface which is vertically above the focus is called the epicenter. Okay, are you getting my point? Here I'm showing you this picture. Look at this picture very carefully, you can easily understand this. It means the earthquake first it occurs in the crust of the earth, and the earthquake occurs, it means that energy is created. This energy is transferred towards the surface of the earth, and at what point that energy is concentrated on the surface of the earth, that point is known as the epicenter. Okay, it means on the surface where actual earthquake happens. See, as the rock settles into a new position, there will be many smaller uh, earthquakes. These are shown as aftershocks. Here, what these rocks when they get settled in the new position, it means what is this? This is the movement of the rocks. This is the movement of the layers of rock from one place to another place. When they get to the new position, it means the movement creates, and the energy is only created because of the movements. So these earthquakes are known as the aftershocks. Okay, then see what are the causes of the earthquake. When the tectonic plates move, they push, pull, or slid against each other. It creates the pressure that we have studied already in detail in the first session, that the movements of the tectonic plates. Then here you see, I'm showing you the picture. See, the tectonic plates, how they move, they push, either they push, okay, the first picture here it is that they are pushing, these plates are pushing each other, then either they pull each other, okay. So the second picture it is showing how the tectonic plates are pulling towards uh, each other, and the third one is the slid against each other. So the third position, third picture, that is showing the same, how the tectonic plates slid against each other, okay. So these are the movements of the tectonic plates. The accumulated pressure is released in the form of vibrations called waves, okay. When these plates are being moved, okay, when these plates are pushing each other, pulling each other, or sliding against each other, that time what happens, it creates the pressure, okay, it releases the pressure, okay, it releases the pressures, and these pressures create the vibrations, and these vibrations are called the seismic waves. As I'm showing you here the picture of the seismic waves, how these seismic waves are transferred from one place to another. The place of origin of an earthquake is called the focus, that already we have studied in the previous slide, and I'm again showing you the same picture to you, that the focus of the earthquake. The point on the earth's surface which is vertically above the focus is called the epicenter, okay, the point of the earthquake on surface. The maximum impact of earthquake is felt in the areas at around the epicenter, okay. Here the maximum effect of the earthquake, maximum impacts of the earthquake are found all the places which are near to the epicenter. Why it is? Because the total force generated from the crust of the earth, it is totally concentrated on the particular point. That point is called the epicenter, and this energy, this wave, these waves are then generated from one place to another place. So therefore the surrounding area of the epicenter also get impacted by the earthquake. These seismic waves travel in all directions from the point of the origin, just like ripples of the water, okay. It means if you just throw a stone in the stagnant water, how it makes, that it makes the waves are created, that waves are the round and round waves are created, and from the point at what you had thrown the stone, okay, from that point the circles are created, okay, like that waves are created here in when the earthquake happens, but these waves are of the waves of energy. So the measurement used for recording, here we are going to study how the earthquakes are measured. So the instrument that is used for recording and measuring the seismic waves is called the seismograph, okay. That is the instrument to measure the intensity of seismic waves, okay. What is that? Seismograph. And the graphical representation of the ground motion is measured by the instrument called seismograph, okay. See the difference between the two instruments, don't get confused in this. The first is the seismograph and the second one is the seismogram. The instrument which is used for the measurement of the seismic waves, okay, get very clear. The instrument which is used for the measurement of seismic waves is called a seismograph, and the ground motion, okay, is calculated or measured by the instrument. That instrument is known as a seismogram, okay. See, the seismogram helps in the determining the time of epicenter and focal depth of earthquake, okay. It means the here the geologist they can predict, okay, they can give us the prediction of the earthquake with the help of the seismograph, with the help of the uh, study made of the earth surface and crust with the help of the seismogram. So they can determine, okay, they can gauge the time of the epicenter. It means the time of an earthquake, in which area the earthquake will can occur in the coming days or in coming times, okay, and from where the earthquake can be created, and what would be the focus and what would be the epicenter of earthquake, that is predicted by the geologist with the help of the instrument called seismograph. Then the strength of an earthquake is usually measured in the Richter scale. Okay, the earthquake is measured in Richter scale. Here, some examples of the Richter scale are given, that in Indian Ocean, the earthquake was happened in 2004. The intensity of that was 9.1 Richter scale. Okay, so that is the measurement, the scale. In uh, generally the distance is measured in the kilometers, okay, like that the earthquake is measured in the Richter scales. So here each level on the scale is 10 times greater than the one below. See here, I'm showing you the picture here, in what way the scale is shown here. Okay, so each scale is 10 times greater than the one below. It means this 1 to 2. 2 is 10 times greater than 1. 3 is 10 times greater than 1. Okay, like that, this is the scale. This means that an earthquake with a score of 7 is 10 times more powerful than with the score of 6. Okay, 6 Richter scale, 7 Richter scale is 10 times powerful than the 6 Richter scale. Okay, the most serious earthquakes are in the range of 5 to 9. Okay, uh, 5 Richter scale to 9 Richter scale, these are the most serious, disastrous, terrible earthquakes, we can say that. Why? It is because when the 5 Richter scale earthquake happens, then the buildings get damaged. At the 6 Richter scale, buildings get collapsed. 7 Richter scales, the ground can be seen shaking. Okay, you can see with your eyes that the ground is moving, it is shaking. Okay, then at the 8 Richter scale, you can see that large buildings are also destroyed, totally destroyed. And if the 9 Richter scale earthquake happens, then it gets the complete devastation. Okay, it means, that's why it is said that most serious earthquakes are in the range of 5 to 9 Richter scales. Then after the measurement of the earthquake, we will turn towards the distribution of the volcanoes and the earthquakes in the world. Almost of 2/3 of the world's volcanoes are found in the coastline surrounding the Pacific Ocean, popularly known as the Pacific Ring of the Fire. See here, I'm showing you the picture. In this picture, there is the Ring of Fire. See, it means the area surrounding the Pacific Ocean, all the coastal area of the Pacific Ocean. In these areas, most of the time volcanic eruptions are found and the earthquakes are found. Therefore, it is known as the Pacific Ring of Fire. Okay, if you look towards the picture, you can see there the red triangles are shown. Okay, the full circle of the coastal line of the Pacific Ocean is filled with the red triangles. What they are showing? They are showing the earthquake prone zones and the volcanic eruption prone zones. Okay, therefore this area, this ring is known as the Pacific Ring of Fire. Strings of volcanoes and site of earthquake activity around the Pacific Ocean is because of the subduction of the oceanic plates beneath lighter continental plates. Okay, this why these strings are made, why this is known as the Pacific Ring of Fire, because of the subduction of oceanic plates. Subduction means movement of the oceanic plates. They are coming closer or going away from each other. Okay, so the plates beneath the Pacific Ocean, they always make movements. Okay, because of that, most of the earthquakes and volcanoes are found in the uh, coastal areas of the Pacific Ocean. The world distribution of the earthquake prone zones coincides with that of the volcanoes. The region of the greatest seismicity falls in the circum-Pacific belt, that we have already studied, that most of the time earthquakes are found in the Pacific belt. The rest of the seismic as well as volcanic activity is recorded in the mid-continental belt, comprising alpine mountains, then Mediterranean Sea, Africa, and the Himalayas, and the mid-Atlantic ridges and its adjoining islands. Okay, adjoining, it means the islands which are joined to the mid-Atlantic Ocean or the ridges. The mid-Atlantic ridges is a zone of moderate earthquakes caused due to the divergent lithospheric plates that we have studied in detail in the last session about the divergent movements of the lithospheric plates. We mostly find dormant and extinct volcanoes in the region of the mid-Atlantic ridges. So here students, with the distribution of volcanoes and the earthquake here, we are going to conclude with the chapter. And here in this chapter we have studied about the movements of the tectonic plates, the theory of the continental drift, as well as the endogenic movements, sudden movements, volcanic eruptions, and the earthquakes. So here we are going to conclude the session. Thank you.